So chapter 8 is on arithmetic and geometric sequences. So just a quick definition of a sequence. A sequence is basically just a list of numbers. And there's certain ways the numbers are put together, but it's a list of numbers. So like 2, 4, 6, 8, ... And we're going to talk about two types, arithmetic and geometric sequences. So when you think of the word arithmetic, it comes from arithmetic. So what operation do you think goes with arithmetic? What operation do you generally think of for arithmetic? So arithmetic usually goes with the idea of adding, so the operation of adding. So your definition of an arithmetic sequence is on your yellow sheet. But it's basically a sequence where you get from one term to the next by adding some amount, some constant amount. So I wrote in adding on my little sheet. Adding goes with arithmetic. You get from one term to the next by adding this certain number. And this number you add is called your common difference. Okay, so your common difference is what you're adding to get from one term to the next, or it's the common difference between any two terms in a sequence. So your common difference equals your second term in your sequence minus your first term. Ran out of room. In symbols, we usually write common difference as D equals your second term, so we label the second term as A sub 2 minus your first term, A sub 1. So we use A, and whatever number's next to it tells us which term it is in the sequence. So an example of finding the common difference. I want to find the common difference for this sequence. Well, I'm going to take my second term in the sequence. So your second term, that's A sub 2. Your first term is A sub 1. Your difference equals A sub 2 minus A sub 1. In this case, A sub 2 is 4 minus A sub 1 is 1. So your common difference is 3. And you can see 3 is what I'm adding to get from one term to the next. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. And I can keep going and find all the terms of the sequence just by adding 3. But that's kind of a pain if somebody asked you what the 80th term of the sequence is. So for stuff like that, we have a nice formula, okay, to find any term. So it's on your yellow sheet. It's the formula for the general term of an arithmetic sequence. So this formula I can use to find any single term you ask. So if you ask me to find the 100th term, I don't have to sit there and add 100 times. So it's A sub n, that's your nth term, equals A sub 1, which is your first term, plus n minus 1, and n is the term you're looking for, times d, which is your common difference. Okay? So example. Find the fifth term in the sequence by writing a formula for the nth term. So here's the sequence: -2, -7, -12, and so on. So my general formula, without anything filled in, from the yellow sheet is A sub n equals A sub 1 plus n minus 1 times d. So the information that I need to fill in here is the A sub 1 and the d. Well, A sub 1 is your first term in the sequence, so that is -2. And we find our difference just like we did it up here. Your difference equals A sub 2 minus A sub 1. A sub 2 is the second term in your sequence. So a sub 2 is negative 7 minus your first term, which is negative 2. Negative 7 minus negative 2 is negative 7 plus 2, which is negative 5. So my common difference is negative 5. So now I can fill in my formula. So a sub n equals a sub 1, which is negative 2, plus n minus 1 times d, which is negative 5. And that's my formula. Now that I have this formula, I can find any term they ask me to. But they asked me a specific one, so that's one we're going to find. They asked me for the fifth term. So the fifth term is a sub 5. Okay, fifth term, a sub 5. So a sub 5 is going to equal negative 2 plus, well, I'm looking for the fifth term, so my n is going to be 5. 5 minus 1 times negative 5. And you're all excellent at simplifying, so you get this and you're going to see you get negative 22. So the fifth term in the sequence is negative 22. Okay, so we have a word problem for arithmetic sequence. It's word problem 1 on your yellow sheet for this section. When you're doing arithmetic and geometric sequence word problems, it's really helpful to take the situation they give you and try to write out a few terms of the sequence. So here's our word problem. In 1970, 11% of Americans aged 25 and older had completed at least 4 years of college. On average, this percentage increased by 0.5 each year. Part A, write a formula for this percentage for n years after 1969. And Part B, find the percentage of Americans who completed at least 4 years of college in 2019. So first off, we're talking about years after 1961. So that's kind of the defining point for our sequence. So let's look at the first few terms. So 1 year after. What would be my percentage in 1 year after? Well, first off, what's 1 year after 1969? Well, that would be 1970. And what does my problem say the percentage is in 1970? 11%. So 2 years after. Well, what's going to happen the next year? What did it say it was going to do? It said the percentage was going to increase by 0.5. So that means I take my percentage from last year, and I have to add 0.5 to it, and I get 11.5%. What about 3 years after? What's it going to do? Well, again, it says every year it's going to take what was there and increase 0.5%. So I had 11.5 on my previous year, and it's going to increase by 0.5. So what do we get? 12%. So my sequence here is the numbers 11%, 11.5%, and 12%. So how are these numbers changing? How am I getting from one number to the next? By adding this 0.5. So we're adding something that tells me it's an arithmetic sequence because we're adding it. And the thing we're adding is called our what? It's called our common difference. So that means your D, your common difference, is 0.5. Okay? And then the general formula we're looking at to write a formula is a sub n equals a sub 1 plus n minus 1 times d. The other piece of information I need is a1. So what's a1? Well, a1 is the first year. It's the first term in your sequence. So it's 11. Now we just substitute in a sub n equals a sub 1, which is 11, plus n minus 1 times my common difference, which is 0.5. And that's my formula. This is my answer to part A. That is the formula. Part B asks me a specific year. Part B asks me, what is the percentage in 2019? The trick here is, remember, my terms in my sequence aren't the year number. Okay, remember this was 1 year after, this was 1970. Okay, but my term in my sequence was the first term in my sequence. It was the number of years after 1969. So here I'm not looking for 2019, I'm looking for the number of years 2019 is after 1969. Okay, so 2019 is 50 years after 1969, so I'm looking for n equals 50. So for my sequence, I'm going to do a sub 50 equals 11 plus 50 minus 1 times 0.5. And I'm going to get, if you do that, I trust in your ability, I'm going to get 35.5, and we're talking about percentages, so percent. So a sub 50 is 35.5%. So there's arithmetic sequences. Now let's talk about geometric sequence. So when we talked about arithmetic sequence, the operation was add. Geometric sequence, the operation we're doing to get from one term to the next is multiply. So you'll see on your yellow sheet, you have the definition of a geometric sequence. You're getting the first term, the next term by multiplying the previous by something. So I wrote up to the side here, multiply. We're multiplying here. And since we're multiplying a specific amount each time, that number we're multiplying by is called the common ratio. Okay, so arithmetic is adding, you have a common difference. Geometric is multiplying, you have a common ratio. So your common ratio it equals your second term in your sequence divided by your first term. Or to put letters for it, common ratio, we can call R. My second term, remember we call our second term a sub 2 divided by our first term, which is a sub 1. So an example of finding your common ratio, so here's my sequence, 1, 5, 25, 125. I'm going to take, find my ratio, by taking my second term, what's my second term in the sequence? 5, and dividing it by my first term, which is 1. 5 divided by 1 is 5. And you can see I'm multiplying by 5 to get from one term to the next. So 1 times 5 is 5. 5 times 5 gets me to 25. 25 times 5 is 125. Multiply 125 by 5 to get to the next term. And I could keep doing this forever and find all the terms in the sequence, but that's a real pain like it was previously if you asked me to find the 80th term. So we have a nice formula to use for this as well to find any term in your sequence. So here it is on your yellow sheet. The nth term of a geometric sequence, we call that a sub n. We get that by taking the first term in the sequence, a sub 1, multiplying it by r, our common ratio, to the n minus 1 power. So let's get an example of that. Write the formula for the nth term of the geometric sequence and find the 6th term. So here's my sequence. -2, 6, -18, and so on. So my general formula for my yellow sheet is my nth term a sub n equals my a sub 1 first term times r, my common ratio, to the n minus 1 power. So the pieces of information I need to fill in here are my a sub 1 and my r. Well, what's my a sub 1? It's my first term, so that's -2. How do I find my ratio? We'll look right back up here. It's my second term divided by my first term. My second term is 6, so 6 divided by -2 is -3. So my ratio is -3. My first term is -2. So now I just need to fill this in. So my formula, a sub n, equals my first term, which is -2, times my ratio, -3 to the n minus 1. You want to make sure if you've got a negative, you put that in parentheses for your ratio. That way that negative also gets the exponent, because the whole thing's part of the ratio. So just use parentheses here. Okay, and then it asks me for the 6th term. So the 6th term would be a sub 6, and based off this formula, that's going to be -2 times -3 to the 6 minus 1. 6 minus 1 is 5. And I trust your calculating ability. You should get a sub 6 equals 486. So your 6th term is 486. Okay, that brings us to word problem 2. So word problem 2 deals with geometric sequences. It's on your handout. So a job pays a salary of $24,000 the first year. Every year the salary increases by 5%. What would the salary be in year 10? So just like with arithmetic sequences, it's helpful to start writing out what's happening like year by year to really get a feel for what's happening. So year 1 of your job. How much does it say you're going to get paid in year 1? Well, your starting salary is $24,000, so that's how much you're getting year 1. Year 2, what do they promise you is going to happen? Well, they promise you a 5% pay increase. So let me ask you, year 1, what percentage of your salary were you getting paid? Well, weren't you getting your entire salary? You were getting all of it, $24,000. That was your entire salary. So what percentage goes with everything, with all of it, complete? Well, that's 100%. So you were getting 100% of your original salary. Now they say, no, you're not getting 100% anymore. We're giving you a 5% increase. So now what percentage if I'm getting, if I was getting 100% and now they're giving me a 5% increase? Well, that would be 105%, okay? So they're increasing me by 105%. So we do that by taking your 24,000 and you multiply it by your 105%. But remember, when we multiply by percentages, we don't use the percentage. We have to change it back to what form? Change it back to decimal form. So 1.0 or 105% goes back to 1.05 as a decimal. Okay? So that's your salary year 2. Whatever you get, and multiply that together. I'm going to leave it like this because we're going to keep building. Year 3. They say, okay, whatever you made last year, we increase that by 5%. So I take whatever I made last year, and that gets increased by 5%. And what do we multiply by when we increase by 5%? Well, just like we did here, we multiply by 1.05. So I have everything that I made last year, which is my 24,000 times 1.05, but I get an increase this year of 5%, so I multiply again by 1.05. Year 4. Again, they promised me something. They promised me a 5% increase from my previous year's salary. So how do we increase by 5%? Well, we take whatever we made in the last year and multiply it by 1.05. So that's 24,000 times 1.05. This is what I made last year. And it gets multiplied by 1.05 for another 5% increase. So I hope you can kind of start seeing a pattern with what's happening here. Each time my change is happening because I'm multiplying by a number, okay? I'm making the same change every time. I'm multiplying by the same number every time. So in our geometric sequence, this number we multiply by to get from one term to the next every time is called our what? It's called our common ratio. So our common ratio, R, is the number we multiply to get from one year to the next year. And what am I multiplying by to get from one year to the next year? Well, every year I multiply by another 1.05. So my common ratio is 1.05. And what is my first term in my sequence? Well, my original salary is 24,000. That's my first term in the sequence. And this is all the information I need to be able to fill in my general formula. So for my yellow sheet, the general formula A sub n equals A sub 1 times R to the n minus 1. And based off what I found right here, I know my formula is A sub 1, 24,000, times my common ratio, 1.05, to the n minus 1. And now that I have this formula, they ask me specifically what's the salary going to be in year 10. Well, year 10, that's going to be A sub 10, your 10th term in your sequence. So based off this formula we just have, I can find A sub 10 equals 24,000 times 1.05 to the 10 minus 1. Again, I trust your calculating abilities. You should get 37,231 and 87 cents when you calculate that out. The last little bit of this section is just recognizing which sequence is geometric and which sequence is arithmetic. Okay, so the way we do this is we basically just find the common difference in ratio based off your first two terms and see which will form your sequence. Goodness. Sorry, I can't see that. Okay, see which one forms your sequence. So for part A, I'm just going to pick to calculate one of my things. I'm trying to see if it's arithmetic or geometric, so I want to see if it's got a common difference or a common ratio. And I'm just going to pick one. We're going to start with the difference. That's one we learned first. So your difference equals your second term minus your first term. In this case, my difference is 7 minus 2, which is 5. So I want to see, remember difference is adding, okay? You're adding to get to each new term. I want to see if I add 5 to each piece will get me to the next piece. So yes, 2 plus 5 gets me 7. But does 7 plus 5 get me 12? Yes, it does. Does 12 plus 5 get me 17? Yes, it does. Okay, so 5 works. Five works as the common difference, so it's going to be arithmetic. Part B, we're going to work the same way. So I'm just going to try and find the common difference and see if it works. So D equals A2 minus A1. In this case, that's 6 minus 3, which is 3. So I want to see if adding 3 gets me to each new term in the sequence. So 3 plus 3 is 6. 6 plus 3 is 9. So does adding 3 to 6 get me my next term? It does not. So that means it is not, this does not work. So it's not arithmetic. But I also need to check geometric now that I know arithmetic doesn't work. So I'm going to calculate my ratio. A sub 2 divided by A sub 1. So that would be 6 divided by 3, which is 2. So I'm going to see multiplying because ratio is multiplying. So 3 times 2 gets me to 6. 6 times 2 gets me to 12. 12 times 2 gets me to 24. So 2 works as the common ratio. So we are geometric. And that wraps up chapter 8.